Welcome everyone. So here we're looking at normal distribution and hypothesis testing in the context of normal distribution. Now, whenever you're doing a hypothesis test, there are two particular methods that are available to us. We have a p-value method and we have a critical region method. So I'm going to use this example in order to flesh out both methods. My recommendation, however, is to use the critical regions method. So in this question, we're told that a certain company believes that the average customer waits for 180 seconds before being answered, with standard deviation 6 seconds. An independent review of 40 calls finds that the average waiting time is 183 seconds. Assuming that waiting time follows a normal distribution and using a 5% level of significance, test whether or not there is evidence to support the claim that waiting time is longer than 180 seconds. So the first step is to write down the null and the alternative hypothesis. The null hypothesis is what the company believes to be true, in this case based upon historical experience, which is 180 seconds is the waiting time. So that's H naught is such that mu equal 180. So this is a template for writing down a null hypothesis, H naught being the symbol for null hypothesis. If the null hypothesis is not true, then there's an alternative hypothesis that we will accept, and that's called H1. The alternative is that there is a claim that the waiting time is longer than 180 seconds. So therefore, mu may be more than 180. In order to administer this test, we need to know what is the distribution of the average waiting time. And according to the central limit theorem, regardless of what the distribution of x is, x bar, the sample mean always follows a normal distribution with mean mu and variance sigma squared over n. In the context of this problem, mu would be 180, sigma would be 6, the standard deviation, and n is the sample size 40. When we evaluate square root of 6 squared over 40, we will get 0.949 to 3 significant figures. So a p-value question is asking, what is the probability that x bar is greater than or equal to 183? If it is smaller than 5%, then we know that 183 falls in the critical region and we would reject H naught. So this is called the p-value method. So we're asking ourselves the question, what is the probability? Is the probability that x bar greater than 183, we can ignore the equal sign, is that less than or equal to 5%. All right. So if we go to our calculator, we're going to go to normal, then we're going to go NCD. So our lower will be 183. Our upper is an arbitrarily large number, 1,000. Sigma is going to be 0.949, and mu is going to be 180. All right, so this gives us 7.86 times 10 to the minus 4. So this is going to be below or less than 5%. So we're going to answer yes, and we're going to reject H naught as true. So our answer will be, our decision will be yes and reject H naught. So our conclusion would be there is insufficient evidence at the 5% level of significance to support the claim that the average waiting time is 180 seconds. All right, so that would be the conclusion, and that would complete the question. All right, so let's also look at the critical value approach. So the critical value approach requires me to solve for the critical value that corresponds to 5%. I'm now going to use the inverse normal method to find the critical value, and then check whether or not 183 lies inside the critical region or outside the critical region. So we go to distribution, normal, inverse normal. The area will have to be leftward facing, so it will have to be 0.95 for this calculator. Sigma is going to be 0.949. Mu is 180, and we get 181.56. So A is equal to 181.56. So notice here that 183 is going to be on the right hand side of 181. So 183 will lie inside the critical region, and therefore it will lie inside the rejection region. So that approach, I believe, is the cleaner way of doing a problem, but the decision is yours. And so our decision remains the same. We're going to reject H0 because, and then we say because the sample value lies inside the critical region. And then we would conclude that there is insufficient evidence at the 5% level of significance. And notice I include the level of significance in my conclusion. So there's insufficient evidence at the 5% level of significance to support the claim that the average waiting time is 180 seconds. So that concludes this presentation. Stick around for a couple more examples.